For activity 8.2, what is reasonable, you will need to log into the student portal. So go here, and then you will have to use this applet right here to answer the questions. So for the first question, it says, what is the probability that you will flip heads when using the coin you have? So I just want to clarify that for this particular lesson, we're looking at probability, okay? We're looking at how I can use these statistical measurements or these ideas to prove or disprove a claim, okay? That's all it is. We are moving away from the standard deviation and mean as it was explained in the previous lesson, but we still will refer to it every now and then. So what's the probability that you will flip heads when using the coin you have? So think about what you have, right? In a coin you have tails or heads, a tail or head. So what is that? It's one out of how many options, right? So that will be 1/2. So that's simply 1/2 or equivalent. Now estimate the number of heads you will get when you flip the coin 20 times. So that will be up to you. I did this many times and I always got a different number, but we can do it right now. So it says when you flip the coin 20 times. So let's see, let's flip it. You can see how the numbers are changing, so essentially you just have to count until you get to 20, and then you will see the number of flips. And if for some reason you're not able to get these or access this website, just get any other, just type in Google coin flip applet or calculator, and you will have plenty. GeoGebra has one, so you can do that. So in this case I got 11. You might have gotten 10, maybe 9. So the idea is for you to use the applet, or you can do it with a coin if you don't have access to this. You can simply get a coin and then see what you get. So for this one, it will be 10. I got 11 in mind, but this is just a sample, right? A sample answer. Okay, so this is where you will have to either do it by hand or use the applet. Flip your coin 20 times and record the number of heads you get. Repeat this process 4 more times. So you will have to do these 5 times. Obviously, the first one, they don't count it because they assume that you already did it. But go ahead and do this 5 times and then record the number of heads you get every time that you flip it 20 times. These answers that I'm going to show you are simply a sample response. You will probably get, for sure, you will get different numbers. So I will encourage you to try it so that this makes sense. So go ahead and take a minute, 2 minutes to do that, and then come back, and then I'll show you the answer. So this is a sample response of what they found. Okay, you might have different numbers, and that's fine. This is just an example. But in average, I guess the number shouldn't be that off. Now, for the next problem, it says here that you need to ask the class for data, but you can create your own. Okay, obviously it's gonna be a sample with not a lot of data points. That's why we will prefer to be in class to do this with a lot of you. But since some of you are not able to connect or whatever the case might be, or probably you didn't have access to the applet or you're doing it on your phone, whatever the case might be, let's just assume that this is how it would look if I were to ask you in class to use your data to plot the dot plot. So you can see here the number of heads in 20 flips. So the next answers are based on this plot. Okay, if you create your own, then you're gonna have your own plots, your own set of answers. If you want to collaborate with other students after we do this, that's also fine. But let's just concentrate on this particular one because these answers that I'm about to show are based on this plot. So what is the fewest number of heads flipped by the class in 20 flips? What is the greatest number of heads flipped by the class in 20 flips? So you can see here what they're asking you. So the least amount, it says here, let's go back, fewest of the numbers, it will be 4, right? Obviously these numbers are by random. These might not be your numbers, but I'm just using this one. And then if you look at what's the largest, okay, what's the greatest number? Well, let's just look at what's the greatest number here. That would be 16. So therefore, the fewest number of heads flipped is 4, and the greatest is 16. And it says, based on the class dot plot, describe a range of values that represents a reasonable number of heads to flip when flipping 20 times. So again, I mean, this might depend, but looking up here, it seems that these are outliers, with maybe this one is the outlier. So it seems reasonable to say that it's between 6 and 16. And you can clearly see here what shape is this, right? So about 6 to 16 seems reasonable. Now, this is where the probability and the reasoning comes, and this is the portion of the lesson that it's the objective, right? To answer this question. So I don't know how to pronounce that name. Is it Priya? I don't know. However you want to pronounce it. Flips her coin 20 times and it lands showing heads twice. So is it possible for this to happen with a fair coin? So for these ones, you have to choose a side and defend it. Okay? So here they say it's possible, but it's very unlikely. You might say, it is not possible, and it's not very likely to happen. So you're choosing a side, and then based on the distribution, okay, and in this case based on your distribution, we come up with a proof, okay, or not a proof, but we come up with something that's going to back up our answer. Why are we saying that, right? So it says, based on the class distribution, should she be suspicious of this being an unfair coin? What can we do to provide evidence that it's not a fair coin? So again, here you have to look at what we have, right? So if we go back here, it seems that the number of heads in 20 flips, it seems that 10 is the average, okay? And if you think about it, I mean, so she should be suspicious, maybe for some of you, and some of you might say, no, it looks that it's fair, but I think it should be suspicious. But let's go back to I don't know. Okay, so let's go back here. So it says that 10 is the average number of heads in 20 flips. So in order to provide evidence that it's not a fair coin, this person should just do it, okay? Maybe do it one more time. Just maybe do it one more time, these 20 flips. And if she gets around 10, then we can probably say that it's fair, right? But at first, I'll say don't let yourself just be fooled by the statement without looking at some sort of evidence. And you might say, how can I use this in real life? I think what's happening right now is a perfect example of how statistics is used in the real life. For example, look at the cases of coronavirus, the death cases, right? How many people have died in the United States due to the coronavirus? And then look at the total amount of people living in the United States. So do the math, right? Like look at the number of deaths and divide it by the amount of people here in the United States. We are around 330 million, something like that, people. So out of those, what's the percentage of people who have passed away? I mean, each strategy, regardless if it's just 0.01% or even if it's just one person or two people who've died, it's sad. However, this is the type of analysis you have to do when you are giving a statement, but you're also giving the numbers to prove what you're trying to either prove or disprove, right? So that's why statistics plays a very important role in any field, sports, medicine, finances, because you have tangible data to compare it and analyze it.